This is part 2 of the homework from chapter 6. We're going to be doing problems 51, 55, and 59. Let's begin. 51 reads, calculate the final speed of the 2-kilogram object that is pushed for 22 meters by the 40 Newton force on a level frictionless floor. Assume the object starts from rest. All right. This is 51. This is fairly easy. We're going to use the work energy theorem. So the work equals delta EK. All right. So FD cos theta equals 1/2 m v final squared minus v initial squared. That's the work energy theorem. So force is, what was it, 50 newtons? Let's see, 40 newtons. 40 newtons times, what was the distance? 22 meters. Cos 0. Let's see, I want v, we know this term is 0. It starts from rest. So times 2 divided by m, which would be 40 newtons divided, oh no, that's a force. Let's see, 2 kilograms, 2 kgs. So all that is going to equal to 29, under the radical, sorry, because that term is squared. That equals the final, which equals 29 meters per second. And there you go. That was 51. All right. Pause and let's move on. All right, 55 says a catcher in a baseball game stops a pitched ball that was originally moving at 44 meters per second over a distance of 12.5 centimeters. The mass of the ball is 0.15 kgs. What is the average force that the glove imparts to the ball during the catch? Okay, so let's see. We're going to again use the work energy theorem. So delta EK, because that's what we know this time, equals FD cos theta. All right. So delta EK, 1/2 m. V final is 0, V final squared minus V initial squared equals the force, which we're solving for, times the distance times cos 180, right? All right, so we know it's going to be negative. This is -1. All right, okay, 1/2 times m, what is this 55, right? 0.15 kg, 0.15 kgs. V final is 0 minus V initial was 44 meters per second, and this is quantity squared. And let's see, equals force, and then we'll divide it by the distance. This is going to be negative, right? And this is, let's see, the distance is what? 1 second. 12 centimeters, so 0.12, 12.5 centimeters, meters. And our force, if you do all that math, is going to be 1,200 newtons. This negative here cancels out with that, so 1,200 newtons. There you go. All right. 59 reads, an object attached to the free end of a horizontal spring of constant 450 newtons per meter is pulled from a position 12 centimeters beyond equilibrium to a position 18 centimeters beyond equilibrium. Calculate the work the spring does on the object. All right. So let's see. We have a work of the spring. equals to the negative integral of 0.12 to 0.18 of f dx. The force is equal to F of the spring is the spring constant times X. So we're going to have equals 0.12 times 0.18 F X dx equals Kx, sorry, this is Kx, okay. The spring constant equals K x squared from 0.12 to 0.18. Oh, and there's 1/2 there, right? Yeah, and that, taking the integral of that. All right, so if we do that math, we're going to get a negative 4.1 joules. And we know that the work done by a spring is negative 1/2 kx squared. That's a formula. So, and we just proved it with calculus here. All right, and that concludes the homework from chapter 6.